Milan Delor, who is a physicist by training,
Yeah.
but I don't think he's going to talk about physics.
Right, so I'm Milan Delor, and I'll talk to you about my third mini project, which is on energy access ecosystems, which you will soon understand. I worked with Professor Talcott from the management school, and in collaboration with Practical Action. Practical Action is an international NGO which tries to solve poverty issues by means of technology. And they are releasing a yearly publication called Poor People's Energy Outlook, which basically looks at, it gives an in-detail view of energy poverty in many countries in the world. And they try to come up with a framework for action. And in last year's publication, they gave an introduction of the idea of representing market structures as ecosystems, because it has very similar dynamics. They only introduced this idea and asked me to maybe look further into it and give a theoretical framework to see how far we can take this analogy. So why is energy access so important? Well, this table here on the right is Practical Action's what they call total energy access standards, which look at the minimum requirements which you need to say that a community has energy access, for example. And the important part here really is these requirements are absolutely essential to the healthy development of a community. And these requirements are lighting, heating, cooling, cooking, information and communication systems, and earning a living. Without energy, without access to modern energy services, you cannot have any of this. And the importance of this was recognized by the UN Secretary General, who called for universal energy access by 2030. He also recognized that it was a major obstacle to the Millennium Development Goal. And when you look at the figures that show, well, for example, that 57% of India is without electricity, globally you have 1.5 billion people without electricity, and 3 billion without access to modern fuels. So the situation is extremely urgent. We need to act as fast as possible. The problem is that bringing energy access, universal energy access, is really difficult because it's a real multi-dimensional problem. This graph outlines the problem by showing the kind of spread in social structure that you have with many poor people living in rural areas and many richer people living in urban areas. And the thing is that to bring universal energy access, you'll need to satisfy every layer of the social structure. So you'll need to have energy services that are affordable for the poorest people, as well as having energy services that are that satisfy everybody else. And that requires a large variety of actors to be involved in the market. You need people to bring in appropriate technology, and you need also people to be able to build centralized power stations. So the real difficulty here is to have many players in the market, like community-based organizations, micro-enterprises. You also need small and medium enterprises. You need large companies, public utilities. And all these players in the market, they interact. You also need things like universities and training programs, etc. And the government is also part of the market in that context. And the interaction between all these market players are basically the same as what govern natural ecosystems. And those are competition, collaboration, co-evolution, and adaptation. And because the dynamics between those market players are the same, that's where the analogy comes in to compare market structures with natural ecosystems. And the purpose to do this is to have a kind of overall systemic understanding of the market structures and to be able to identify where you can kind of have entry points to have strategies for change and to have a framework for action. And the next couple of slides, I'll just give some applications of this analogy. We know that all natural ecosystems are built from the same fundamental building blocks, which are in DNA, RNA, cyanobacteria, etc. So everything has been built with a bottom-up approach. If we extrapolate this to energy access ecosystems, we can see that basically we need to prioritize this area of the social spectrum to try and bring up basically the poorest communities to a higher level, better quality of life. So we really need to build everything with a bottom-up approach. And this will involve basically using appropriate technology instead of large centralized power stations, for example. It will involve a lot of local civil involvement, small-scale involvement from CBOs, NGOs, and just community programs. And you'll also need some financial institutions to mobilize microfinancing so that people can set up small businesses and go up from there. Another interesting application of this is to look at how natural ecosystems can be affected by the introduction of exotic or foreign species. We know, for example, with the accidental introduction of the zebra mussel in the Great Lakes of North America, that introducing a foreign species can be extremely dangerous and have devastating effects. In this case, the mussel basically colonized all the bottom of the food chain, and all the endemic species which were relying on that food chain basically died. That raises interesting questions about the kind of foreign interventions in countries, mainly by big multinational companies, for example, because they have the power to basically monopolize the market, drive out all the small businesses in the competition, and that's really bad for the local economy, or can be bad for the local economy, and for the social status of the people there. Also, it shows you that technology, when it's imported in a country, if it is imported, it can be sometimes very expensive and very complex, and people in the country where the technology is used maybe do not have the capacity or the skills to maintain and repair the technology, and it therefore becomes obsolete because you need foreign intervention to use it, etc. It becomes very expensive. So all technologies must be adapted and appropriate for the countries where they're used. So how do we know whether an ecosystem is healthy or not? Well, a natural ecosystem has, we look for three qualities. We need productivity, you need resilience, and diversity. These are very similar qualities that are looked for in business ecosystems, which are basically showing how firms like Microsoft and Walmart, big firms, work. And we can extend that to energy access ecosystems, because these qualities, they lead to sustainable and self-managed markets, which is exactly what we're looking for. The real challenge is basically to, how do we measure this health of ecosystems? And what you need to do is to develop a list of indicators which can give you a quantitative measure of the health. And for example, if you want productive ecosystems, you can look at two things. For example, return on invested capital, which will give you an indication. But the problem with that is it doesn't consider natural capital, which can be free. It doesn't consider labor, social, and environmental costs. So a better indicator, especially for energy access, is to look at value added, which takes into account these costs. For resilient ecosystems, if you have a shock, what you could look at is the survival rates of the ecosystem members, and therefore have an indication of the resilience of the system. So what we did was to develop lists of indicators under three headings: policy, finance, and capacity. I don't want to go into too much detail here, but just to say that a lot of these indicators, you can just extract it from data banks that already exist. For example, the Ease of Doing Business Index, which we put under policy, is a well-known World Bank ranking system, so you can just extract that data. Some, however, indicators, like the survival rates of ecosystem members, you'll need to have consultation workshops in situ in the country with experts in the market, which will tell you what's going on. And Practical Action are, as we speak, holding those consultation workshops in various countries. The kind of overall picture that we want is progress in these indicators. These are well-known indicators that show basically progress in energy access. And things like the multidimensional energy poverty index is a well-known UN index. And if we have progress in these indicators that correlate with progress in these indicators, and we'll find that out soon, then the model can be looked into further because it'll tell us that it's more or less viable. So just to conclude, energy access is absolutely crucial for the healthy development of countries. And when you look at the figures that show that 1.5 billion do not have access to electricity and 3 billion do not have access to modern fuels, we can see that the situation is extremely urgent. The thing is that it's a real multi-dimensional problem to bring energy access to everybody. And so we need a very diverse range of market players that get involved. They need to interact together and they need to work and collaborate. The dynamics that will govern these markets are very similar to natural ecosystems. And so we take this analogy further, and that allows us to look from a systemic point of view how we can change these market structures so that they can better bring energy access to the world. And we can also monitor how these ecosystems change by the use of indicators. And as I said, practical action is now in Peru, Kenya, and Nepal, holding these consultation workshops. So we should soon have some figures to see whether it correlates or not. Thank you for your attention. Any questions?
Thank you, Milan.
Firstly, how realistic do you think that the energy access indicators are? Because looking, a kilo of wood per person per day doesn't sound like enough that you could feed yourself on unless you had a big community barbecue or bonfire with it. And secondly, with the indicators that you said to look at with the healthy ecosystem, few, if any, ecosystems that I can think of fulfill all three criteria. Are you saying that your ecosystem market ecosystem doesn't need to fulfill all three, or would it ideally have those, or the indicators that it fulfills need to be suited for the particular use of the energy? So like in Peru you might want a robust one, but in a city in England you might want a productive one.
No, ideally, I mean, of course, the indicators will be adapted to the country that you're looking at. But ideally, you do need these three qualities. And actually, most natural ecosystems do have these qualities. If you look at, for example, a permaculture farm, which uses these principles, the ecosystems will be both productive, resilient, and they will also be quite diverse.
But you said a farm, not like a healthy.
No, but a permaculture farm is basically reproducing the ecosystem to try and be as productive as possible. And if you look, for example, at a healthy forest, woodlands, for example, they are extremely productive, diverse.
But how would they be resilient to, say, a 2-degree rise in temperature? They probably wouldn't deal that well with it.
No, but yeah, but I mean, I don't know if you've heard of ecological succession, for example.
Yes,
a woodland will resist forest fire, for example. It will start again, so it's extremely resilient in that sense. A 2-degree rise in temperature, well, we don't know because we don't know what that's.
I'd argue that it would change rather than resist that high chance.
Yeah, it will adapt, of course. But that's part of the resilience. Yeah, it will adapt, I think. But yeah, the other question?
The indicators, how realistic they are.
These indicators, you mean these ones?
Energy access indicators.
These ones, or the
no,
total
the ones
energy
that
access?
says like what quantities of cooling and heating.
This? Right. Well, this is just an attempt by practical action to try and basically have a minimum standard that should be achieved. I mean, it's hard to really define what is the minimum standard that is needed, but that's a good attempt already. And so if you look, like, we say 1 kilogram of wood fuel is not enough, but
well,
it depends what you're using.
Do you feel these are realistic, or?
Well, yeah, it depends what you're using, because if you're using efficient cook stoves, then it will certainly be enough. I mean, they've done a lot of research to find these minimum standards. So I think Personally, yeah, I think they're quite good, but it's really minimum standards that we're talking about here, so it's preferable to have more, of course.
Very pleased to see our new first-year eFuture students getting stuck in.
Yeah, it's great.
So thank you for that.
We'll have some good debates over the year.
Yeah. Any more questions?
Yeah.
Over the back, yes, please.
Most like ecosystems, like in this situation, like the analogy would be dominated by a kind of fossil fuel based system. Did you find any strategies for kind of subverting that and trying to get rid of that dominant system and putting in a renewable energies one?
Yeah, absolutely. There's been a lot of research into this actually, and they've shown that basically for these ecosystems, as I said, you need a bottom-up approach, and you'll need a lot of independent power producers for that. If you have a reasonable financial mobilization from institutions, which will allow you to have to set up businesses with microfinancing, it's actually more viable in many of these countries to have renewable energy technologies rather than fossil fuel-based technologies. And I include biomass with this, so I don't know, depending on definitions. A lot of stuff is based on biomass. But yes, indeed, for independent power producers in most less developed countries, it's much more economically viable and much better in the long term to have renewable or biomass-based technologies rather than fossil fuel ones. So that's another interesting point as well, that we could straight away start developing renewable systems. But the interesting thing also is that if you do bring universal energy access by these standards, even if you use only fossil fuels, you'll only increase carbon emissions by 2% worldwide, which gives you an indication of how much we are emitting, you know. Because yeah, just 2% increase is nothing compared to what we could do by decreasing our consumption.
Okay, thank you. I think we should move on. So thanks again, Milan.